Hi guys, my name is Dana McDonald. I'm back. I'm going to be showing you guys how to work with sheet metal in SolidWorks. Unfortunately, I'm not going to be using other programs this time, even though last time, if you were there, it wasn't much of a tutorial, mostly just me jumping through more hoops. But yeah, I don't know how to use sheet metal in other programs or if it's even available in other programs. But SolidWorks has a wonderful set of sheet metal tools that we're going to be using. So here is the link. I posted it in my earlier stream video. But here you're just going to be able to find all of these drawings that's going to be available. And these were sort of like an assignment, sort of not. If you made one, you can sort of check as you go along. If you haven't made one, then you can follow along. So this first part, just a really simple bearing gusset. So we have 1, 2, 3, 4 bends, pretty simple part. We can just get started. So when it comes to sheet metal, you just start like you're making any other part. You start with the sketch, select your plane. I have to specify which measurement system I'm using, and it's really annoying. But then you can just make your regular sketch. We're going to make this about 1.5 by 2.5. And then we're going to put a hole in the middle of it. Dimension that out, 1.125. How does that look? That looks fine. And then we'll dimension this out to be something like 0.75. Yeah, that looks pretty good. We can make this vertical, and then that'll be nice and fully defined. Yep, looks all good to me. And then right here, so I have it on the side here because I work with sheet metal a lot, but chances are you do not have it already on your toolbar. So what you'll be doing is you'll be going over to, I believe it's the Tools tab, and then looking at, actually maybe it's in Window, View? Toolbars, yes. So you're going to go to View, you're going to go to Toolbars, then we're going to go, so I have sheet metal selected. I don't have the rest of these selected. I have these two, I don't know why. And I have blocks. I use sketch blocks a lot, they're very handy. But yeah, this is just really simple. Then you're going to do create base flange, or it'll say tab as well. We're just going to use all these default parameters. Actually, I don't know if they're default for you guys, but this is just what I'm going to be using. It's just 1/10 of an inch sheet metal, and then we can hit check. If you're using sheet metal frequently as a team, I would highly, highly, highly recommend you guys develop a set of standards and then write them down, stick to them, make sure everyone knows the standards, no one is confused, and then go from there. Because if you don't get the standards right, someone might like do some funky stuff with a bend, and then you send it off to the machine shop, or you give it to your students to bend, and it comes back all wonky and cattywampus, and that's not what you want. That actually really messed up our 2020 season because we kept getting these drive bases back that were completely messed up. So what we're going to be doing is we're going to be taking the edge flange tool, and we can just drag it out, click and drag out, and then we're just going to use default radius because I'm not picky. And then right here, this is the bit we want to pay attention to. I'm just going to say 1.5 inches. We can make it 1 inch. Yeah, 1.5. Yeah, that looks good. Then right here, this is the really, really, really important part. So flange position. If you want, you can see, so this is the part that we defined. This edge right here is 1.5. If you want the outside of this to the outside of this be 1.5 inches, you use this. If you want the inside of this to the inside of this to be 1.5, you use this. If you want to do other things, you use bend out and bend from all these different ones. But what you would use bend outside if you've got something like a cut going up to the very edge, and then you want the bend to be outside of that, so then you don't have to deal with that. But that's also annoying to deal with. So what I recommend you do is use material inside, because it's much easier to account for, in my opinion. Actually, no, I'm not going to do that because ours is a little close. So we'll just be using material outside. Not much of a big deal anyway, but if your team has standards, stick to those standards. So yep, that works for us. And so now we've got this sheet, this C shape, and then we're going to go back to edge flange. And we're going to select this edge. We're going to come out, select this edge, come out, and then we're going to call this 0.375. Actually, no, we're going to call this 0.5. And then, let's see. Okay. So since we did this before, we're going to stick to this. Actually, no, we're going to do this because we want everything to be flush. So this isn't good. Just heads up, your machine team is going to be really mad at you if you do this, because you have two different types of bends in a single part. They're really not going to like that. They're really not going to like you if you do that. So to make it easy on them, stick to one, develop standards like I said, and then it'll make everyone's life a whole lot easier. So now we've just got this basic shape, and then I'm going to be fancy. I'm going to put a chamfer on this edge. I'm going to put it at like, see, how does 60 degrees up, 30 degrees look, and then we'll put it in like an inch and a half, 2 inches. That looks good. Yeah, see, that looks good. And we'll do the same on the other side. Then we'll have to change this because it does a weird thing. Oh, and then we'll have to do like 1.5. Oh, no, wait, we'll do flip direction. So we're doing 30. Then we're going down 2 inches. Yep, cool, great, wonderful. Simple enough. And then if you were actually making this to serve a purpose, down here you would put some holes for rivets or bolts. I would recommend using rivets, especially for something like a chassis. But let's talk about why I did it like this. So what this is supposed to be for is an intake would be mounted, the axle that the intake pivots on would be mounted to bearings that sit inside here. So why did I go for this design and not something simpler? That's sort of like the whole thing with sheet metal. So, I mean, the simplest design would just like, I don't know, take a piece of 2x1, some VersaFrame, and cut a big circle in it and stand it upright and put a gusset on it or something. I don't know. But since we're working with sheet metal, we can make these nice, pretty parts. So I wouldn't want to just make like a straight L. Like I wouldn't want to make, let me just make an example here. So yep, this is all cool. This is all good and dandy. I wouldn't want to make a part that looks like this because, I mean, I guess for certain situations you can do this, but for what this is, it's a whole intake. I mean, you've got like a decent amount of stuff that's going to be on this. You're going to want some support for it. So you're definitely going to want to do something more like this style where you sort of fold it in like a C, and then you fold in the bottom wings of the C rather than make an L like this, because you have to sort of look at like where your things are going to be pushing you. Since this is going to be, I mean, this if it deforms, let's see, markup. If it deforms this way, oh, whoops. Then if it were the regular L, then it would just bend. But since it's not the regular L, it's like a reinforced, don't know what to call this. It's not going to do that because it's mounted technically to the sides. That's pretty much what all this is. It's just sheet metal design is mostly just looking at how things are going to be supported and how to bend them and assemble them properly to where whatever forces you have aren't going to be tearing apart your pieces. So if you made something in this kind of shape for that little assignment, nice job. If you didn't, not a big deal. So long as you learned sort of how to do it this way, and that you had all these flush and you had everything dimensioned out pretty nicely, then yeah, I think you're good. So with that out of the way, we can get on to the more complicated piece. That is all these elevator pieces. So we have this one, we have this plate here, and we have, let's see, where is it? And then we have this one where we have things going at a 45. So we actually can't bend anything at a 45, so this isn't going to actually be on a real robot. This was actually pulled off of our CAD-a-thon robot. So I don't know exactly. I wouldn't use this as like the poster child for anything sheet metal. If you are looking for a poster child, I would look to 148 or 1114 or 2056. They have a lot of really, really pretty sheet metal. especially 148. All right, so for this, we're just gonna start with the back piece. So really arbitrary value, doesn't really matter to me. We're gonna go with 12 inches. And then we're gonna do this. This one actually matters a bit. It's gonna be 1.5 inches. So we can hit check mark, and then we can do a base flange. So, yep, same as normal. And then this is where I have to think a little harder. So we're gonna do a 45-degree angle, and then we're gonna do it the same for this one as well. And then what I have to, yeah, I think I wanna do outside. Okay, yeah. And then the flange length, we're gonna make it 1. It should be about √2, right? Yeah, so I had to check on my calculator, 1.414. But we're gonna estimate that to 1.415. And then, yep, looks good on the other side. Cool, great, wonderful. Then we can check that. Cool, looks great. Then this is the important part for this piece. Whenever we make our mounting flange, which we're going to put right here, and we're going to do material inside. Once again, switching up the, sorry, one sec. We're going to do material inside because this piece and the front piece are going to be wedged between 2 panels. And so I'm just going to keep material inside so I know the exact distance between the 2 panels. That will just make everything a lot easier. So we're going to make this 0.5 again. And I did this on the outside. So all these are going out. Now, why did I do this? Whenever we have the plates, we're gonna have one right here, one right here, and then we're gonna have one right here. Then we're gonna have some space, and there's gonna be the thing that's gonna be right here, and the plate's gonna extend over here and do all this. But this one's actually outside because I'll explain that in just a sec. But for this, the force is gonna come down like this. It's also gonna come from this way, but if the force is coming down like this is also important for drivetrains. Then if you have it out like this and then the plate's like this, then it's going to allow this to go from straight up and down. It'll allow it to either bow in or bow out. And then that will mess up your thing. It'll be lower, then it'll screw up this, and it'll be all slanted and all weird, and it'll suck. You don't want that to happen. Oh crap, I messed up. Can I just exit markup? Oh crap, that's really bad. Can I erase all these? My markup has now broken. Oh, okay, cool. I'm just gonna ignore that. Cool. Yep. That looks kind of funny. Anyway, so I'm just gonna save this to my WWWVROX folder. I'm gonna call it the elevator backing. We'll go back and we'll change this later. Oh, also really important to do like these things all as one single feature, because if you do it as separate features, it gets really annoying having to go back in. Like if you change your standards or something and you want to instead make it like 0.75 or 0.375 or something, it's just really annoying to go back in and select everything over. Just keep it to one feature so it's easy to go back and fix. New part. We're going to be making the slanty one that looks like that. So I have to actually look at the drawing for this. So that says 13.31. This one says 13.42. Okay, so they're about the same. What about this? Okay, so for this, these two are equal, and then, oh, okay, cool. Okay, yeah, great. So going back to my part, I can, oh, whoops, that's not what I want to do. Sketch on here. No, no, there we go. So we'll go back to what we did before with the 12" by 1.5 inch. So 12 inches, 1.5. Check. And then we can base flange. Check. Okay, and then this is where we get to the fun part, where we make this go out, and we make this go out. And then I want that to be, I think I did material, I think I did material outside. Oh wait, what did I do? Crap, I forget already. I'm so bad at this. Oh, I'm gonna do this because that'll make it easy whenever I'm making the plates. Yep, that works for me. And then I'll put this as like 1 inch or something. Yeah, that works. And then I'll make another, oh, whoops, that's a sketch flange. Another flange right here, and then that's going to be another 1 inch. And then, do I want it right there, or do I want it? Do I want that? No, I want. Right now I'm thinking of where my plates are going to be. I think I want this. Yeah, I think that's what I want. Okay. Yeah, that looks great. And then I'll do what I did before, but I'll do it backwards. Because this part of our elevator is going to be holding the load, but it's not going to be holding as much load as the back plate. Just because of how the robot was made, it had things going on. So we can, come on, 0.5. Oh, can I not? Ooh, I can't. Ooh, wait, that's weird. I guess I have to make, oh, wait, what's going on? What are you doing? Oh, I see. I just had to reselect it. I got really confused there. I was like, oh, I can't select that. If I sound delusional and like little out of it, it's 5:41 a.m. Wait, I suppose that doesn't hold a lot of weight because it's like 6:30 whenever this will be playing. Huh. Whack. All right, and that's what I want. Yep, material on the inside, so it's the same size. Perfect, 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 perfect. Yep, that's exactly what I want. Now there is a thing right here. I believe it's right here. So trim side bends. I'm pretty sure that would be like this little bit right here. If I didn't want that, I would do, like if I wanted it for some reason, I would keep this. I believe that's what it is, if I'm remembering right. If I'm not remembering right, ignore me. Problem solved. All right, and then that'll load. All right, cool. And so now I've got all these funky weirdo parts. Now I just need to make the plate that will connect them. So elevator fronting, fronting. I hope that's not something non-PG. Okay, so now I just need to make the piece that will connect all these together. So I will sketch again. All right, and then make my rectangle. Again, 12 inches. Then this is gonna be my distance between my two plates. So I want that to be, if my plates are like 0.5 away from each other, then like from the edge, then I'm gonna want something like, yeah, 1.5, that works. Been doing it this whole time. Yep, okay, cool. And then we're gonna do something along the lines of this, and then like that. All right, and then so I just made a trapezoid here. Then I'm just gonna dimension this out. This is 1 inch. Oh, whoopsies. Whoopsies, I made a little oopsie. Oh, all right, then I can dimension this out to be 1 inch. Please work. Cool, yes, wonderful, it works. Worked the first time. And then this is 1 inch from here, I think. I don't even remember. 1 inch, and then that's 1 inch, so that works out. And then all we gotta do is power trim. Then make a nice line that's vertical right here. And then we're gonna make this infinitely long. Woohoo! And then, can I? Oh, I can. Yes! That's exactly what I wanted. And I'm gonna just define this because I want to. 6 inches. Nice. I'm not super picky right now about having this be fully defined. It's just the icing on the cake if it is. Then I'm gonna mirror this about this. And then I get a nice piece. This is, wait, no, I don't want to extrude boss base. No, that's not what I want to do. I want to do this. And then, yep, regular sheet metal part. And there we go. So let me talk about, I don't know if this is right yet, but before I do, I'm going to talk about the other stuff. So we've just been using edge flange, and edge flange is super, super, super nice. But it won't work for everything you want to do. So they give you a butt ton of tools, and sometimes you can just do it with edge flange, but like doing a jog is just one thing, one operation. And so if you go down the line and you're making like complex parts, but you want to be able to reference them in like equations at like the assembly level, then you could just have a jog instead of having two edge flanges, and then just sync it up to your equations nice and neat. Yeah, so that's pretty much what most of these are for. Yeah, I probably could have just done a corner trim on that other part. Then there's corner relief if I wanted to do that, but I really don't care. Is there anything else? Oh, sketched bend. Yeah, sketched bend is pretty important. Everything else, like we can look at hem. Hem is just doing that and you make it all curly. I don't know why you'd want to do that, but I guess if you're weird. Oh, so I don't like this. I don't like this tool. Yeah, I'm pretty sure this is sketching. Oh, what's the equivalent? I don't even remember. But I'm pretty sure it's like, yeah. So I'm sure there's some equivalent in features. Yeah, like swept boss base or even lofted a little bit. But it's like extruding, except not extruding. It's bending on a sketch. So that can be good if you don't want to do sketched bends and you're doing something a little complicated. Because sketched bends can be really annoying. So just delete these, please, please delete them. I don't like them. Ugh, I hate it. Just get rid of it. 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 All of it. Exit sketch. Go back. Cool. All right, we're back to where we were. And then sketched bends. It's pretty similar to the miter, except, oh, whoops. You just make a line on a part, and then you exit the sketch, and then you select that line in the sketch, and then it makes your thing. And then you can, I mean, it's just like edge flange, except if you have like funky things that are hard to do with an edge flange, you can do it with this, and then you can make it funky angles. And then you can do all the regular things with the edge flange. But due to the limited manufacturing capability at Mars, you're not going to see us use anything beyond edge flange. So yeah, that covers most of the stuff you're going to need to know as an FRC team. If you're getting into like industrial level sheet metal, I don't know why you're listening to me for instructions. Yeah, that's about it. Bottom plate. Cool. There we go. So now we can make our assembly from this. What is important is that everything lines up nice and neat. So we'll put this down, and then we'll put our insert components, our backing, Plop that in. Oh, it even gave us the ugly markup thing I made. That's cool. So we'll make that coincident. We'll make this, if I did it right, should be coincident to that. And then I'm pretty sure I did this one wrong. Yeah, I did. Booyah. That's not right. How do I fix that? I think I need to do the bends on the inside with that. So then we go back to our parts and we're like, what went wrong? And I think it's this one. So I edit the part and I put them on the inside instead. I hit the check mark. And we go back to the assembly and oh, it's better. No, it's still somehow bad. Ew. Why? So we're going to use the tried and true method of why is this wrong? How far is it wrong? So this is horrible. Wow, I hate that number. 0.2459393. Cool. Wonderful. Measure this one to this one. 0.1145685. This minus, oh, what? That's multiply. Whoops. Ew, that's an even worse number. I really hate that. Oh my god. Ew. Gross. So there is not a good solution to this. The good solution is don't do 45-degree bends. The sucky solution to this is find the difference, subtract it from 12. So minus 0.1313708. And you know what? That's good enough for the CAD-a-thon. That's the only time I'm going to be using 45-degree bends. So let's look at the assembly. Rebuild. Oh, and what do you know? It just happens to be the right length. Now, all we need to do is measure this to get it about flush with this. And that is it's 0.165. I don't care. So we're going over to this one. And then we are editing this feature again. Minus 0.165. Then we shorten that up, check mark, and then check on the assembly. It should be about, really? Oh my god, dude, what even? You know what, I don't care enough. I don't care enough to even bother. That's staying like that. I don't care. Now we just add in the other piece, which is probably screwed up, which is the front plate. This one, open up. We're gonna flip it so it's right. And then, okay, this is where it gets super, super duper fun. Flip it, coincide, and that should work. And then, where did we go wrong with this? Oh, that went a lot better than I expected it to. And yeah, wow, that's really nice. Then all we have to do is evaluate. And it's 0.1. Cool. So I'm just going to go into the part, subtract 0.1. Yep, just make sure that's all good. And then that should be, yep, that's all we needed to do. Now, there is the really annoying part of, so normally you wouldn't do it perfectly coinciding with this. You would, actually, it was better before, actually, no, it wasn't. So what we would do is we would, see, that would be wrong. This one, yeah, we would edit this. So we would change this to be this. What just happened? Can you flip that? Okay, dude, whatever. All right, and then this is where you would get something like this, so it just goes out a little bit, and that it looks a little nicer, but it doesn't help you at all. Actually, I think it makes it worse because you are now the part that's actually holding weight is out beyond a flat thing that can also support weight. So it can distend and deform. But whatever, because pretty points. And then we're going to be putting in this bottom plate again, except it's on the top again. Wait, not again. I don't know, dude. I'm really tired. Make that coincident. And we make this coincident with this. Oh my gosh, it is so wonderful. Look at that. Ain't that just great? And then the reason why this is 1.5 tall is because if I go into markup, with the Versa frame, there'll be a hole right there and a hole right there, and that'll be spaced out about, well, exactly 1 inch. And then, whoops. Erase, 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 erase. And then, oh, there's going to be markup. So there's going to be a bunch of holes here. So if you did this as an assignment, you might have seen some of the parts actually had holes on them because I didn't suppress them before I made the drawings. So they're going to have rivet holes that go along like this. When you make these, I would recommend putting them in the most complicated part, like this piece, because it's really hard to dimension everything out. And then I would go in and I'd go to assembly features. I'd do a whole series, and I would just whole series the entire thing, because, and then you can do it through all both or whatever, because, oh my God, it is horrific trying to make, I mean, it's like what we just did, but like times a million, just a million cajillion times worse, trying to align the holes. It's absolutely brutal. So I would just go make a whole series. Then all you have to do is change the holes on one part to change the holes on all the parts. Isn't that much nicer? It is. Yeah, that's what I would do, because it just makes your life a whole freaking lot easier. So yeah, that's sort of a basic crash course on sheet metal. to sort of summarize, you want to make sure you're prioritizing where the force is going to be going. You want to make sure you have the vertical bits below that. If you put it over, like if you give it a belly, that's assuming that this isn't going to be taking a whole lot of the weight. Hole pattern instead of align your holes. Make your parts to where they can, again, look for how the forces are going to be coming on it, and then just adapt it to be better suited for it, and be sturdier. And then, yeah, don't use the hem tool. That's about it. So this is the last time you'll see me tonight. If you're up right now, why? But thanks. And I hope you guys really have fun with this.